However, we can't always encrypt, we found out, guys. Why? Because sometimes I need to perform operation on the data. And to do that, it needs to be plain text. You cannot, for example, perform database queries on encrypted data. You cannot do select star from blah where ID equals 7. Well, the data is encrypted. So how do you do that? The only way is to actually either have it plain text, unencrypted, stored on disk, which is pretty much what we do today, or have the database store it encrypted, but when we want to perform the queries, we decrypt the data using the key, and then we have to deal with the key management and stuff like that, which is another hassle, right? And then turn around and encrypt it again. So that's what we can do today. There is no solution. That's what we do. Twitter, same thing. They cannot encrypt their data. Nobody encrypts their data in the database today, right? Why? Because not only that, they want to run trends, right? Twitter want to run trends. They want to run their analytics. They want to compute recommendation. They can't keep decrypting and encrypting on the back end, right? They cannot do that all the time. Maybe you can, but it's always there will be an agent that decrypts at the end of the day, and the agent that decrypts, if you don't trust it, tough luck. Analysis, indexing, database tuning, can't do any of that. Has to be unencrypted, right? Tough luck, right? Applications must read the data in order to process it, right? Even if the data is encrypted on disk and you read it encrypted, right? So whoever snoops in the network cannot really read it, but the moment it reaches you as an agent, as an application, as a backend application, as a web server, as an Express, as Node.js, as Python Django, you gotta decrypt it in order to make sense of it, right? And once you do that, it's available, right? And the question is, do you trust this application or not? Who knows, right? So, same thing. We have this concept of TLS termination on layer 7 reverse proxies and load balancers, right? All load balancers that act at the layer 7, if the traffic is encrypted with HTTPS, it has to say, stop, I need to look at the data. What does it do? It terminates TLS. What does that mean? It means it serves the load balancer certificate to the client and decrypts all the traffic, looks at the data, look at the GET request, look at the POST request, look at the path, and then based on that, execute rules that you have put on the application. So I can know your host, I can know where you're going, I can know the path, and I can execute microservices logic, right? So hey, if you're going /pictures, then I'm going to take you to this set of backend servers. If you're going to /comments, I'm going to take you to this backend servers. You cannot do this if you don't decrypt. Today we decrypt, TLS termination, and reverse proxies. Apparently they brag about the features. Hey, we do TLS termination, we're good. Well, it is a feature, all right, but you're decrypting the traffic, and there are a lot of people against this concept, right? Steve Gibson is one of them, and we're gonna reference the video below. He says, "I'm not gonna give you a reverse proxy or load proxy or DNS protector to look at my traffic just to do your operations. No, sir, I'm not gonna give you my private key and certificate to serve it." He's just not comfortable with it, and so many other people are not comfortable with layer 7 reverse proxies, right? That's the nature of the beast, I guess, right? But that's why people prefer layer 4 load balancers, where just it will stream all the way to the backend. Well, it's efficient. It's not as efficient as layer 7. Okay, you cannot do pooling, cannot do all that stuff, but that's a big problem in the backend engineering community today. TLS termination.